Hello everyone, this is Dr. Surya. Now we are going to solve a problem on jet of water on a stationary vane as well as on a moving vane. So this is the problem given to us. A stationary vane is having an inlet angle of 0 degree and outlet angle of 25 degree. So it means what? It is striking the plate in a horizontal way with 0 degree, and after striking the jet of water is moving with an outlet angle of 25 degree, and then we are receiving the water at a velocity of 50 meter per second. So at initially we are having a velocity of 50 meter per second. We are asked to determine the force on it and the direction of jet velocity and normal to it, and also we are asked to find the resultant forces magnitude and direction per unit weight of flow. So this is the diagram given to us. So as I have mentioned earlier, V is going to be the initial velocity. The water is striking here. So after it strikes, it is getting deflected with 25 degree. Okay, now we are going to determine the force in the direction of jet. So which is we have to determine both f of x and f of y. So the formula for f of x is mass striking per second into initial velocity minus final velocity. So this is the formula. So we can write our f of x as mass per second. I am denoting my initial velocity as v1x and final velocity as v2x. So in the problem, my v1x is given to me, which is 50 meter per second. I have to calculate my v2x. So initially there is no angle for it, so my initial v1x is 50 meter per second. But once it strikes, there is an angle for it. So I have to note that also. In the x direction, what is going to be my final velocity? So which is nothing but we are using minus 50 into cos 25 degree, because this is the adjacent side, and moreover why we are denoting in minus sign is, so here if you see the water is moving in this direction, and while returning back it moves in the opposite direction. So we are putting a minus sign here. So which is equal to minus 45.315. Next, we have to determine our force. So force is equal to mass per second into initial velocity minus final velocity. So my final velocity is 45.315. Again, in a problem it is given to us per unit weight of flow. So we have to determine the force per unit weight of flow. So which means that I have to find weight of water per second divided by weight of water per second. So weight of water per second, we can denote it as mg. Why? Because mg is weight is a force that acts due to gravity. So I can write the formula as weight of water per second is equal to mass per second into gravity. So mg. So since because here 1 second is there, I am including that also. So my force Fx now it becomes mass per second into 50 minus of minus 45.315 divided by mass per second into gravity. So this and this will get strike off. So I'll be getting 95.315 divided by 9.81. So which is 9.716. So I've got my force. So next is that I have to determine my f of y. Here also the same formula, which is mass per second into initial velocity minus final velocity. So since because it is in y direction, I am writing f1y minus v1y minus v2y. So if you see in the diagram, there is no water that is flowing in the y direction initially. So my v1y will be 0. But my v2y, water is flowing because there is an angle here. So my v2y is nothing but 50 sin 25. Okay, so since the y direction, it is going to be in the same direction like this. Water will be like this. So after striking also it is going like this. So I have not mentioned any minus sign here. So I'll be calculating my Fy is equal to mass per second into V1y minus V2y. Again we have asked to determine by weight of water per second. So this can be written as mass per second. My V1y is 0 minus 50 sine 25 divided by mass per second into gravity. So my f of y is equal to 1 by g into 0 minus 50 into sine 25 degree. So my g value is 9.81. As you all know. So my Fy becomes minus 2.154. Now I have to calculate my resultant force. So resultant force is nothing but, again, per unit weight of water. So which is nothing but root of Fx square plus Fy square. So I have already calculated all my Fx square and Fy square. So 9.716 square plus 2.154 square. So my resultant force Fr is equal to 9.952 Newton. Now we have to calculate the angle made by the resultant. So which is nothing but we are going to determine the theta value. So this we can easily determine as tan theta is equal to Fy by Fx. So which is theta is equal to tan inverse of Fy by Fx. So theta is equal to tan inverse of 2.514 divided by 9.716. So theta is equal to 12.50 degree. So this is for our stationary vane. Now we have to calculate the same as such of my moving vane. So second part is going to be moving vane. So which means what? Here there will be a jet velocity as well as a vane velocity. So jet velocity we are going to determine by V, and vane velocity we are going to determine by U. So which means what? Here you will be having water is also moving as well as this plate. This plate is also, it is moving in this direction. So we have to take into account of everything. So here in the problem it is given as vane velocity as 20 meter per second. So which is my U value, and as I all know there is going to be a jet velocity which is 50 meter per second. So the initial velocity will be equal to both the things are moving, that is my water is also moving as well as the vane is also moving. So which is nothing but V minus U. So which is 50 minus 20 is equal to 30 meter per second. Next I have to calculate my V2x, same way, minus of V minus U cos 25 degree. So which is equal to minus 27.189 meter per second. Similarly we have to calculate all the forces. So f of x is equal to mass striking per second into initial velocity minus final velocity as V1x minus V2x. So again here also they have asked per unit weight of water, so which is mass per second. So f of x is equal to mass per second into V1x is 30 minus of minus 27.189 divided by mass per second into 9.81. So this and this will get cancelled. So I'll be getting my F value as 5.829 Newton. Now we have to calculate similarly the V1Y. So V1Y, as I have mentioned earlier, there is no water that is flowing in the Y direction. So next we have to calculate my V2Y, which is nothing but V minus U into sine 25. Okay. Now Fy is equal to the same formula, mass per second into initial velocity minus final velocity, V1y by V2y. So this is a general formula. Since because it is the problem they have asked, we are writing mass per unit weight of water, mass per second into gravity. It will get cancelled. So my Fy is equal to 0 minus of 30 sine 25 divided by 9.81. So I'll be getting my Fi value as minus 1.292 Newton. Now I have to calculate my resultant force Fr. So Fr is equal to root of Fx square plus Fy square. So which is equal to root of 5.829 square plus 1.292 square. So my resultant force is going to be 5.917 Newton. Then I have to calculate my theta. So tan theta is equal to f of y by f of x. So tan theta is equal to 1.292 divided by 5.917. So I'll be getting my theta value as 12 degree 30 minutes. Again they have asked us to determine the work done. So the formula for work done is Fx into U. So my Fx value is 5.829 into 20. Sorry, this value is 5.829. So 5.829 into 20. So which is equal to 116.58 meter per second. Then they have asked us to find power developed also. So power developed is nothing but work done per second. Since because we have to convert divided by 1000, so we are converting it to kilowatt. So this is 116.58 divided by 1000. This 1000 value is we are converting it into kilowatt. So 0.116 kilowatt. So this is my power developed. Happy learning. Thank you.